In this video, we're going to be talking about displaying categorical data. Now we know that categorical data could be summarized in a frequency distribution and displayed graphically using a bar chart. Now bar charts can also be used to give a visual comparison of two or more groups. This is accomplished by constructing two or more bar charts that use the same set of horizontal and vertical axes. Double bar charts. When do we use them? We use them when we have categorical data. To construct them, we make a relative frequency table for the provided data. Then we construct bar charts, but with two or more groups being compared. Now this is important. You must use relative frequencies on the vertical axis, and you must include a key to denote the different bars. So why must we use relative frequencies? Well, the reason is because relative frequencies must be used so that accurate comparisons can be made when sample sizes are different. Now, each year the Princeton Review conducts a survey of students applying to college and of parents of college applicants. In 2009, 12,715 high school students responded to the question, ideally, how far from home would you like the college you attend to be? And also, 3,007 parents of students applying to college responded to the question, how far from home would you like the college your child attends to be? And that data is displayed in this frequency table. So we have less than 250 miles, we've got from 250 to 500 miles, from 500 to 1,000 miles, and then more than 1,000 miles. So what do you do first? Well, we're going to create a comparative bar chart with this data. So our very first step is to calculate the relative frequencies for students and for parents. When constructing a comparative bar chart, we use the relative frequency rather than the frequency to construct the scale on the vertical axis so that we can make meaningful comparisons even when the sample sizes aren't the same. So let me have you go ahead and pause this video, and then I want you to see if you can come up with the relative frequencies, and we'll compare our answers. When you're done, hit play. So here we can see our relative frequencies. So we put those into a bar graph. What does this graph show about the ideal distance college should be from home? I mean, it's easy to see the differences between students and parents. A higher proportion of the parents prefer a college close to home, and a higher proportion of students than parents believe that the ideal distance from home would be more than 500 miles. Now, to see why it is important to use relative frequencies rather than frequencies to compare groups of different sizes, let's look at the incorrect bar chart constructed using frequencies rather than relative frequencies. So here we have our correct bar chart, and here we have our bar chart using just frequencies. So the top chart is using relative frequencies, and our lower chart is using just frequency. The incorrect bar chart conveys a very different and misleading impression of the differences between students and parents. So don't forget, you must use relative frequency to maintain accuracy. Let's talk about segmented or stacked bar charts. When do we use these? We use them when we have categorical data. How do we construct them? Well, you must first calculate the relative frequencies. Then you draw a bar representing 100% of the group. Then you divide the bar into segments corresponding to the relative frequencies of the categories. Here we have an example. So we see that for each group, baseball, hockey, and basketball, the combined bars add up to 100%. And here we see the relative frequency for the win by the home team and the win by the visiting team. Now, remember that Princeton survey? Let's create a segmented bar graph with this data. So first, we're going to draw a bar that represents 100% of the students who answered the survey. Next, we're going to divide the bar into segments. Now, we have 4 colors because remember, there were 4 distances. We had our less than 250 miles, our 250 to 500 miles, our 500 to 1,000 miles, and our more than 1,000 miles. Now, this line right here, this line represents the cumulative relative frequencies. It's the sum of the previous relative frequencies. So we're going to do the same thing for parents. And then don't forget that we have to have a key that says what each thing means. So I want you to go ahead and pause the video, and I'd like you to make the bar for the parents. When you're finished, push unpause, and we'll see how you do. And again, don't forget the key denoting each of the categories. So the parents bar looks something like this, and here we have our key. Notice that this segmented bar chart displays the same relationship between the opinions of students and parents concerning the ideal distance that college is from home as the double bar chart does. Let's talk about pie charts, sometimes called circle charts. When do we use them? We use them when we have categorical data. How do we construct it? We're going to draw a circle to represent the entire data set. Then we're going to calculate the size of each slice. So we're going to take the relative frequency and multiply it by 360 degrees. Then, using a protractor, you're going to mark off each slice. So to describe, you comment on which category had the largest proportion or the smallest proportion. Notice that we still have a title of our graph, of our chart, and we still have a legend that tells us what each of those pieces represents. Now, typos on a resume do not make a very good impression when you're applying for a job. Senior executives were asked how many typos in a resume would make them not consider a job candidate, and the resulting data are summarized in this frequency table below. So notice here we have the number of typos, 1, 2, 3, 4 or more, or that they don't know. Then we have the frequency, and then we've calculated the relative frequency. So we're going to create a pie chart for this data. So first, we're going to draw a circle to represent the entire data set. That's 100% of our data. Now what you should know is that pie charts can be done in Excel, and they can also be done on the TI Inspire if you have that calculator. So now that we have our circle drawn to represent our entire data set, we're next going to calculate the size of the slice for one typo. So remember, that's the relative frequency times 360 degrees. So 0.40 times 360 degrees equals 144 degrees. So we're going to draw that slice using a protractor. Now we're going to repeat that for each slice. So here is the completed pie chart created, and it was created using Minitab. What does this pie chart tell us about the number of typos occurring in resumes before the applicant would not be considered for the job? It tells us that 40% of those who were questioned would only allow or consider one typo to occur in resumes, and that only 3% didn't know. We also know that if we were to add the one typo and the two typos together, that would make up 76% of the employers who were questioned after two typos would stop considering that applicant for the job. So always double check your resumes for typos and grammar. Have somebody else proofread it for you. Now, pie charts can be used effectively to summarize a single categorical data set if there aren't too many categories. However, pie charts are not usually the best tool if the goal is to compare groups on the basis of categorical variables, of a categorical variable, which is kind of shown in the example that we just did. So when constructing a pie chart for categorical data, what you should look for are categories that form large and small proportions of the data set when you're analyzing it.